So good evening, participants. I hope I'm audible clearly.
Yes, ma'am.
Yes, thank you so much. I have shared the sheet which we are using today for correlation and regression in the group. You all can find it. And I'm starting with the session today. So since last 2 days, we have seen, just a minute, I need to, yes. So since last 3 days, we have discussed descriptive statistics, chi-square test, t-test, and ANOVA, one-way and two-way, right? Today, I'm going to discuss the next statistical test, that is correlation, and after that, I'm going to discuss the regression. So give me a second. I'm going to share my screen first. Yes. Yes, I shared my screen. I think I'm showing you my slides. Is it visible or not? Slides are visible?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, fine. So we are discussing with firstly with the correlation. Yeah. Yes. So firstly, I'll talk about correlation and then I'll take the regression. So once we are talking about correlation, from name itself, I think it is quite clear. Correlation means which is telling us the relationship, right? So correlation in statistics is very important analytical test, I must say, because with the help of correlation, we can understand the relationship between the variables. Not only the relationship, but also the correlation indicates the direction of the relationship. We can understand that what is the strength of the relationship between the variables and what is the direction of that relationship using the correlation. So correlation is generally expressing us the extent of relationship between the two variables and how two variables are linearly related to each other. That type of study we can do using the correlation. Usually, correlation is a very important statistical tool because it is a base for many further advanced statistical tools. So I think no, day before yesterday, we have seen the paired sample status also. If any of you have paid attention on the output of the paired sample status, you must have seen this thing, that in the output of the paired sample status also we are getting the value of correlation. So in many of the tests, we are getting the value of correlation because it happens that we can say this thing, that when variables are correlated or related to each other, only then we can find the further kind of statistical, or we can perform further kind of statistical analysis on those variables. So sometimes it is a basic requirement for particular advanced statistical test. So you can see, for example, one example I have written on the slide. It is saying that height and weight of a person are related. Usually, we know this thing that when a particular human being is in the child stage, so we are knowing this thing that the height will be less and the weight will also be less. But as he grows, so height increases and generally weight also increases, right? So we can say that there is a relationship between height and weight. Now, talking about some of the examples which we can observe in our nearby or in our environment also, right? Usually, we have seen so many people, those who are going for the morning walk, they are generally doing the running. So, generally, when we run, the fat of our body decreases. So, maybe possible we can find a relationship between body fat and the running time. How much time we are spending on the running, and what is the impact of what is the extent of the losing of the weight. So that way we can find the relationship between the variables. Similarly, a student who is investing his or her most of the time in viewing the TV, or maybe on a mobile to see various kind of things, reels and etc. So it will possibly impact his or her results, right? So that way again, it is a quite interesting to know that what is the relationship between viewing time and the exam results. Similarly, height and weight, I already discussed. Sales of ice cream versus temperature. So again, we know this thing that usually in the summer, when the temperature is high, generally people are preferring to have ice cream, right? So that way we can say if temperature is high, it can increase the sales of ice cream. So what is the relationship between these two variables? That also we can find using the correlation. Then price of thread and apparels. So again, we know usually for making apparels, we need to have the thread. Using the thread, generally we are able to make the apparels, right? So if price of thread increases, it is quite obvious that the apparel price will also be increased, right? So this way, these are the few examples which we can keep under the category of correlation. So I think till this line, am I clear to all? Is it fine?
Yes.
Okay, fine. Thank you. Now moving ahead and talking about how we can measure correlation. So I think we all have heard about coefficient of correlation, which is generally given by the Carl Pearson. Mr. Carl Pearson has given this coefficient. Using that, we can measure the correlation. So correlation coefficient gives us the measure of strength of relationship between the two variables. We all know that the value of R lies in between -1 to +1. As I said, correlation indicates the direction of the relationship. So using these minus and plus value, we can understand the relationship. If the correlation value, that is R, we are representing this coefficient by small r. So if this value is positive value, that means there is a positive relationship. If it is a negative value, we can call it as a negative relationship, right? So using the value of R, we can interpret the strength also. Might be possible if we are getting the value of R is 0.08, suppose, and for other two variables, we are getting the value of R is 0.89. So it is quite clear. 0.89 means 89%. So we can say there is a strong relationship between those two variables. But when I'm saying the R is 0.08, it is quite clear that the relationship is very weak between those two variables. So that way, it is indicating the strength also. So it is the degree to which changes to the value of one variable predict change to the value of another. So you can see there is a word I have written, which is the predict, but usually using correlation, we cannot predict that. For predicting it, we need to have the other statistical tool. So the capacity of correlation is only to tell us what is the strength of the relationship between the two variables and what is the direction of that relationship. But for the prediction purpose, we need to move for the other statistical test. Then talking about manually, if you want to calculate correlation, so these are the some of the formulae. Using that, we can calculate the correlation. But in Excel, we do not need to be much bother about using the formula to get the value of correlation. Using a small function called as correl, CORREL, using that function, you usually can calculate the correlation, right? Further, talking about the types of correlation. So it is very important to understand. Majorly, we can say, we can call it as there are three types of correlation between the variables: positive correlation, negative correlation, and no correlation. So positive means when the value of R is positive. Negative means when the value of R is negative. No correlation means when the value of R is coming as 0, right? So here you can see, if I say positive correlation, so maybe example can be number of hours of study and the marks, that is the performance of a student in the exam. That way, we can say this thing, it can be or it can show us the positive correlation. If it is a positive correlation and if we are plotting those two variables on a graph, so you can see the extreme left graph in the below graphs. You can see the first one is the positive correlation. So if you will plot your data on a graph, if you are data points are showing such kind of distribution, right? So that way we can say it is a kind of positive correlation. Similarly, negative correlation in economics, we all have studied a law of demand. It is generally when we increasing price, demand decreases. And if we are having such kind of data along with us, we can plot that data on a graph. And if suppose distribution of those data is like this, so we can call it that it is a negative correlation. So the slope is downward. It is upward and it is downward, right? So it is negative correlation. But if you're plotting your data on graph and such type of distribution of data you are getting, so that means you are unable to interpret anything, and that way you can call there is no correlation between the two variables. So this way broadly we can divide correlation into these three categories: positive, negative, and no correlation. Is it fine? Is it clear to all?
Yes.
Yes,
Madam, why
ma'am.
it is called coefficient, madam? Coefficient means?
Coefficient generally we are using for the I can say comparison purpose. Whenever we are using coefficient, there is no unit. It is generally in the percent term, and using that coefficient, you can compare the things. Is it
Ma'am?
fine, sir?
Okay, thank
Yes.
Ma'am, what is the difference between regression and correlation?
That we will see in the upcoming slides, ma'am, because we have to study both today.
Okay, ma'am. Okay, ma'am.
Yeah.
Thank
Okay. So may I switch to next slide?
I have one query.
Yes, sir.
Actually, generally, uh, we spell out like in in matrix calculations, especially when we do image processing. So there is a
Okay.
word that is very famous, like coefficient of correlation.
Yes.
So whatever we are studying here, the things are very much clear. What is correlation? But what is the coefficient? What will be the role of coefficient in positive, negative, and if there is no correlation? So,
Ask. Okay. May
so
I?
please, please,
No,
please.
I think you want to ask something else. You can
No,
add your
nothing,
question. Okay, fine.
nothing,
Okay,
nothing.
fine. So, sir, as I said, coefficient, whenever we are using, it will always give you a facility of comparison, and coefficient is free of unit. As you can see, we are talking about this particular example, number of hours of studies. So that means the data will be having the unit of hours, right? Similarly, marks can be in number, maybe there is no unit, something like that. Similarly, demand, maybe it is in unit, and price will be in the currency, in some particular currency. So there are two different units we are using here, right? So we cannot compare them. So what coefficient will do for us? It will make the data unit free. That way you can take some decision, and coefficient is unit free and it is in percent term. Is it fine?
See, ma'am, thank you,
Okay.
thank you.
Okay. Okay. Any more doubt? May I proceed?
Sure, ma'am.
Yeah.
Ma'am,
Thank you.
ma'am, please. I have a question. Hello.
Yes.
Coefficient of correlation means to indicate relation between two variable in digit. That is not.
No, I'm not getting. Will you please repeat?
To present relation between two variables that we take in our study. So coefficient means one digit from -1 to +1 to express relation between two variables in our study. है ना?
Sir, as I said, 1 means in terms of percent, you can call it 100%. R can never be greater than 1. If you are saying 1, that is 100% relationship. It is a perfect relationship. If you're increasing one variable by 1 unit, other variable will also increase by 1 unit. Or if you're decreasing one variable by 1 unit, other variable will also decrease by 1 unit.
Yes, I got it.
Is it clear? May I move ahead?
Yes, you move.
Yeah, thank you.
Madam, one more doubt. So this correlation coefficient is suitable for linear type of relationship only, not the
Yes.
different like
No.
bell shaped or double dumbbell shaped.
No. Usually,
It is only
Carl Pearson's coefficient of correlation is talking about only linear relationship.
Okay, fine, madam.
Yes.
Okay, thank you.
Now, thank you, sir. So now moving ahead, you can see in terms of arrow, I think I'm trying to express you these relationship. If you are increasing your one variable x, other variable y is also increasing. Or if you're decreasing one variable x, other variable y is also decreasing. Means the direction of change is same. It is called as positive correlation. When the direction of change is same, increasing one, other is increasing, decreasing one, other is decreasing, it is known as positive correlation. Similarly, if you're increasing x variable, y is decreasing, and vice versa. If you're decreasing y, decreasing x, y is increasing. It is known as negative correlation, right? So this way, using these arrows, also you can understand. I tried to explain you this using the arrows about the positive and the negative correlation. So the direction of change is same. It is positive. Direction of change is opposite. It is negative correlation. So demand and price is a kind of negative correlation. Is it fine?
Yes.
Yeah, ma'am.
Yeah. Talking about how you can calculate correlation in Excel. So in Excel, there is a function called correl, CORREL. In that function, we are passing the ranges of our variables, and that way we can get the value of correlation, right? Now, further, I'll explain you regression. But before taking the regression, I'll firstly go on Excel and tell you how you can perform correlation, and then we will come back and talk about regression, and then we will perform, right? So I expect everyone to open your sheet of demo. Miss, I think I have given you a demo sheet, so I'm expecting you to open it, right? And meanwhile, also I am also opening the same sheet. Give me a second. My sheet is visible to all.
No, ma'am.
It is not. Okay. Okay, just a minute. I think I forgot, and I think I have stopped sharing my screen. Give me a second. Again, I'll share. Now, screen is visible.
Yes, ma'am.
Yes. Thank
Yes,
you.
ma'am.
Okay, thank you, ma'am. So I expect to open a very first sheet with the name correlation. I hope this would be a first sheet, right? Now, in this sheet, you can see we are having two variables with the name temperature, and the second variable is sales of ice cream. So these two variables we are having, and suppose we want to perform here correlation. So what would be my hypothesis here? Yes. So we can make our hypothesis as there is no relationship between temperature and sales of ice cream. Is it okay?
Madam.
Okay. So,
Yes, ma'am.
okay. So shall I proceed?
Yes, ma'am.
Yes. Just a minute. Yes. So now what you need to do, you only put a equal sign, write COR. You would be able to get the suggestive option, that is correl. This is a function we are having. You need to pass the range of your first variable without selecting the label, right? Put a comma, pass the range of your second variable, close the bracket. Is it okay? Is it fine? Anyone?
Can you repeat again?
Okay. You need to put a equal sign, write COR, you would be able to get a suggestive function, that is choral. In that, you need to pass the range of your first variable. I have given the range, and then I am giving, after comma, I am giving the range of my second variable, closing the bracket. Is it fine?
Yes, yes, ma'am.
Yes, ma'am.
May I press enter? Yes.
Yes. Answer should be 0.77.
Yes. Thank you. So the correlation value is coming as, this would be your small r. R is coming as 0.77. So it is a positive correlation between temperature and sales of ice cream. And I think it is quite okay, because we know this thing, when temperature increases, sales of ice cream will also increase usually, right? So that way it is coming as positive value. So we can say this thing that this particular hypothesis is not accepted, and we can say this thing that there is no there is a relationship between the temperature and the sales of ice cream. Second way of applying correlation using Excel is, you need to go on the data tab and use the data analysis toolpath. Under this, you would be able to get a correlation option. Is it fine? Everyone is getting it?
Yes.
Yes. Here you can press OK. Now you need to pass the range of your variable, including the labels. I am passing the range. But now you can see grouped by. So it is columns and row. So you can see here data is as per the columns. So I am going with the grouped by column. That is a by default option. We have selected the data including the labels. So I'm selecting this checkbox. Coming to the output options, I'm selecting the first option. Up to you, whatever you want to do, and give a location of a blank cell, and then you can press OK. Is it fine? May I press OK? Everyone is with me?
Yes.
Yes.
Yes, ma'am.
Fine. Thank you. Once you will press OK, you would be able to get your output like this, right? So we are getting the output. Now you can see this. We are getting the temperature in Celsius and sales of ice cream. So we want to see the relationship between temperature and sales of ice cream. So that is sales of ice cream. So you can just turn it. Yes. So this is the value, right? So we can say there is a relationship between sales of ice cream and temperature, and this value is coming as 0.7742. Same the way we got using the Corel function. Is it clear?
No, ma'am,
Yes,
I
ma'am.
just got confused.
Okay. Where from where I need to explain?
Ma'am, we applied the formula and got this 0.77 for this thing when we applied the correlation formula.
Yes.
After that, we used the data analysis toolpath, and we did this, created this table of correlation. But here, since after this, I'm not able to understand.
Why? What is the big problem in that? It is quite clear. It is showing you the relationship between temperature of ice cream and temperature in Celsius and the ice cream or sales of ice cream. What is the problem in that?
Ma'am, this
This
table
is the
again over here,
alternative way.
Sorry?
in the second table, sales of ice cream, it's a blank column. So I'm just a little confused.
Because it is the way this software is designed. So it is means it is quite clear. It is either temperature and sales or sales and temperature. Either we will find the relationship between A and B or B and A. It is one in the same thing. So it is giving you the output in this cell. You can see this. I think you can read the two-way table. This is sales of ice cream. This is temperature. So between these two, you are getting this relationship. What is the big problem in that?
Okay, yeah, got it.
Right?
Yes, ma'am.
Okay, fine. Any other doubt?
No, ma'am, thank you.
Okay, fine. So I think it is clear to everyone.
Yes, ma'am.
Okay, fine. So now this is the correlation, and I think it is very easy to find using Excel also. We are now proceeding with the second tool, that is regression, right? So I'll again switch to the slides. I hope slides are visible.
Yes, ma'am. Yes, ma'am.
Yes.
Yes, ma'am.
Yeah, thank you everyone. So now, as I told you people, or I think one of you have asked me the question, correlation and regression difference, right? So now we will understand what is the difference between these two statistical tools, right? So firstly, regression analysis is a form of predictive modeling technique which investigates the relationship between a dependent and independent variables. So means when I talk about correlation, correlation will only tell you whether the two variables are related to each other, whether they are having any relationship or not. If they are having a relationship, what is the direction of that relationship? But correlation will not bifurcate, or it will not consider whether the variable is a dependent variable or independent variable. There is means correlation has nothing to do with the two variables, and it will not consider that one variable is dependent and one variable is independent. But in regression, we need to be quite clear which variable we are taking as a dependent variable and which variable we are taking as an independent variable. So I think in school time, we all have studied a straight line equation. Can anyone tell that equation for me? Anyone?
Y
And for
is equal to mx plus c.
Sorry?
Y is equal to mx plus c.
Y equals to mx plus c. Very good, sir. Just a minute. I'm just coming on these Word file. Now you can see in the Word file, this is what we did yesterday. Yes. Suppose this is a equation which we can say, I think it is visible, everyone, right?
yes.
Yes, yes.
Yes,
So I have
ma'am.
written, yes, thank you. I have written here y equals a plus bx, right? And I can say this thing that y is my
Dependent.
dependent variable, right? That is dv, or this is my target variable. And x is my independent variable, right? We have seen this thing, I think, in the previous sessions also. So we can say this thing that y is dependent, x is independent. That means x can take any value, but y's value will always be depending upon the value of your x. If you will change the value of x, the value of y will change accordingly. A will be intercept, b will be slope, right? So that way, this is known as the straight line, and usually in regression we can call it as a regression line. This is your regression line. Is it clear?
Yes.
Okay.
Yeah. So here we are interested in predicting what? We are interested in predicting our y variable. Y is the dependent variable and we want to predict it. Say for example, y is a sales, or y is a, we have already seen the previous example for correlation. There was two variable, one was temperature and other was sales of ice cream, or sorry, sale of ice cream, right? Is it clear? So here,
Okay.
can anyone tell me which variable can be the dependent and which variable can be the independent?
Sale of ice cream would be y, and temperature is x.
Very good. X means this would be our independent variable, and y means this would be our dependent variable, right? So
Bec-
here,
Me, I mean,
so, sorry.
we can say that as temperature increases, the sale of demand of ice cream also increases. So sales increase.
Yeah, that we can say, but how much is the change we can observe, that we cannot assess using the correlation, right?
Yeah.
So that we can do using the regression. So that's why we are using regression. So with the help of regression, you can predict your dependent variable. So suppose we are keeping, this is the temperature today. What would be the sales of ice cream today? So that all values we can put here. A and B would be your constant figures, and X you can put here, and that way you can predict your Y. Is it clear?
Yeah.
Okay.
So here we can say that temperature we can take as an independent variable, and sales of ice cream we can take as a dependent variable. So no software will tell you which is your dependent variable and which is your independent variable. This is we who being a statistician or researcher will decide this variable we will take as a dependent and this variable we will take as a independent variable, right? One more thing here, in correlation, I think I explained you one thing. In correlation, what I said, we have found the relationship between the two variables. Yes or no? We have found, right?
Yes, ma'am.
Okay.
Ma'am,
Yes.
ma'am, actually, the correlation is all about it tells the relation between the two variables, but the variables are not defined, right? Like independent and dependent.
Yes, yes. That we are not deciding in the correlation. We are only
Yes,
taking the
ma'am.
two variables and we are finding the relationship between them, right? But
Okay,
here
ma'am.
in the regression, you must be clear which variable will be your dependent variable and which variable will be your independent variable, right?
Okay, ma'am. Got it.
Yeah. Now, talking about
Here, why here, madam, why we are not calling regression coefficient? This is also a comparison. No?
you can say this, B is nothing, B is a regression coefficient. If you have studied the statistics
we can
manually,
call.
so generally B is known as regression coefficient.
Okay.
Yes.
Right.
Okay. So may I proceed?
Yes, ma'am.
Yes.
Yes, yes.
So I think because please keep your questions with you, because one important point I want to tell you, otherwise I forgot to tell you. The point was when I was talking about correlation, right? So we have taken two variable, temperature, and we have taken the sales of ice cream. These two variables we have taken. So I think you people have observed one thing, that both the variables was continuous, right? So these two variables was continuous in nature. So that means once you are finding the Karl-Pearson's coefficient of correlation between the two variables, their nature should be continuous, right? But if you are having the two different variable or the variable whose scale is different, so in that case, Karl-Pearson's coefficient will not be applied. Maybe you have heard about Spearman's rank correlation also. Yes or no?
Yes, ma'am.
Yes, yes.
Yes. So that is we are using for the ordinal data. Right. Now,
Ma'am,
coming,
that is the qualitative data.
yes. Now, coming to the regression, here we are talking.
Ma'am, we can calculate the same thing like Karl Pearson and coefficient relation same way that we calculated.
No, I think in Excel you cannot do that. In SPSS you can do that. In
Right.
Excel you cannot do that.
Okay.
You need to calculate manually in that case.
Right.
Using the formula of Spearman rank.
Okay. Thank you.
Okay, thank you. So coming to the next, if we talk about linear regression, here I'm talking about the simple linear regression firstly, and multiple linear regression we will see afterwards, right? So in simple linear regression, we can say we should have both the variables as continuous variable, right? So here the requirement is these variables should be continuous in nature. Clear? Here for simple linear regression, both the variables should be continuous in nature. Is it fine?
Yes.
Continuous means which considers the decimal point, madam? Decimal values.
Yes.
So here discrete values not considered, madam. Discrete type of values.
Means numeric also we can take. Numeric is including discrete as well as continuous. So you can rather than writing this, you can also write numeric.
Numeric. Okay.
Fine.
Thank you.
Okay. So I think I was on this slide. Yes. Yeah. So now we will talk about regression through this slide firstly. So we have discussed the point number 1. Dependent variable is also known as your target variable, and independent variable is also known as your predictor variable, right? So this technique we are using for the forecasting, for the time series modeling, and for finding the cause and effect relationship between the two variables. So again, very important point is coming, cause and effect relationship. So again, if I'm measuring the relationship between the two variables using correlation, correlation has not that capacity to tell which variable is cause and which variable is the effect variable. But that type of study we can do in regression. We can find the causal effect or causal relationship between the two variables, we can decide this variable is a dependent, this variable are a independent variable, and that way we can find cause and effect relationship between the two or more variables, right? That is regression, right? So relationship between rash driving and the number of accidents by a driver can be the one of the example of regression. Coming to the next, as I said, the regression equation. So I have only told you the equation till this particular point, right? But in this particular line, you can see, in equation, you can see I have added one more term, right? So it is y equals a plus bx plus epsilon. We can read it as epsilon, and this is what? This is the residual or error term. Because once we are doing the prediction of y variable, so it is not like it should be a accurate prediction. There would be quite chances that there could be whatever we are predicting that can be the less than to the actual value, or it can be more than to the actual value, right? And that is known as residual. Is it clear? So y equals a plus bx plus epsilon. Y dependent variable, x independent variable, a intercept, b slope, and epsilon is residual. So residual is what? It is the difference of actual and estimated value. You can represent this by yi minus yi cap or het yi, right? So this is your predicted value. You can see this thing using a diagram also. In this diagram, suppose we are having a data of two variables which we have plotted on a graph, right? And then this is your fitted line, the red line which you can see in this graph. This is your fitted line. These small squares which you can see above and below this line, these are what? These are nothing but these are the error term. So what is the difference you are getting? Means suppose this is your actual value, this is your, because this particular line is what? This is your trend line, this is your estimated line. So what is the difference from these two? This is known as your error term. For each and every point we are calculating that error term, that is known as error in regression model. Is it fine?
Yes, ma'am. The black arrow is the error line.
Yes.
Or the red box or
That-
the
that-
orange box.
This is your estimated value on the red line. This is your
Right.
actual figure. So the difference of these two is the error. So how far this difference or how far these two things are, so that is, the error is very large or very high. We are trying to remove, we are trying to reduce this error in the
Okay,
regression. It should
ma'am.
be less.
Right, ma'am. No arrows are drawn in some boxes. Why it is so? Some are showing some arrows.
Ma'am,
And
it is a diagram you can draw, but otherwise it is very clumsy to explain.
okay, right.
Right.
Thank you.
Yeah. Is it fine? So the line or arrows you are looking above this line, these are the positive errors. So that means you can say actual minus estimated. So your actual value is more than your estimated value. So this is coming as your positive figure. And these below line at the square or below line arrows are the negative errors. That means your targeted value, means your estimated value is greater than to your actual figure, right? So the difference should be actual and estimated should be very less if you want to fit a good model. So for a good model, that error term should be very small. Is it okay?
Yes, ma'am.
Fine. Talking about multiple regression. So in the simple linear regression, we have seen we are having one dependent and we are having one independent variable. But in multiple regression, we will having one dependent variable which is affecting the independent variable, because it is one variable cannot affect a dependent variable. There are so many variables which are affecting or impacting the dependent variable. Say for example, the performance of students in a class. So it is not like they are not paying attention in a class. There can be several factors which can impact the examination, right? So that way it is we can consider under the multiple regression. Say for example, we now want to ascertain the price of a house. What should be the price of that particular house? So you need to see so many factors: the size of a plot, in which locality this plot is, and what is the what I can say locality or of that particular plot. Likewise, you can see so many things, what are the facilities available nearby that plot. So that way we can decide the price of that plot, right? So that in real life we are having, usually we are looking for, or we can say we are having so many examples which are related to the multiple regression, right? You can read this. In statistics, regression analysis is used to estimate the relationship between a dependent variable and one or more independent variables, and multiple regression in Excel is used to predict a variable y based on other variable x or variables x, right? If you are having more than one x, you will call it as a multiple regression. If you are having a single x, you can call it as a simple linear regression. Is it okay? Clear to all?
Yes.
Okay.
Fine. Now you can see the equation. If suppose we are having three independent variables, so this way you can formulate your straight line or your regression line, and you can read it as y equals a plus bx1 plus cx2 plus dx3 plus epsilon. That means y is the dependent variable, x1, x2, x3 are your independent or explanatory variables, and A is intercept, B, C, D are the slopes or the regression coefficient for x1, x2, x3, x4, x5, x6, x7, x8, x9, x10, x11, x12, x13,
Ma'am,
Ma'am, you are not audible, ma'am. Not audible, ma'am.
ma'am, I think network issue.
We should wait a moment.
hello, am I
Yes.
audible?
Yes, ma'am, you're
Yes,
audible.
ma'am.
Yes,
Hello?
ma'am.
Okay. Extremely sorry, there is a power cut in my locality, so I think due to the Wi-Fi connection, I'm now out. I was out of the meeting. I'm just sharing my screen again.
Ma'am, you can put the camera off, so that will help with the bandwidth.
Hello. Any queries?
No, ma'am, you can turn the camera off, so it will help with the bandwidth.
Can anyone tell me what you are to see on my screen?
Ma'am, we can see your screen.
Okay, fine. Thank you. So I was out of meeting. I think I was talking about multiple linear regression equations.
Yes,
Ma'am,
ma'am.
we can
I
see your
think you
PPT.
have question, right? It is not visible.
PPT
Any-
cannot be.
It is visible.
Screen is not
Someone
right.
slide
Slide
screen
not
just,
visible.
just
Not
a
audible,
minute. Okay,
ma'am.
I'm sharing. Not audible or visible. I shared my screen again. It is visible?
No, ma'am.
No, ma'am. No, ma'am. No.
The screen is not visible. I think you will need to.
Not
I
visible.
think you need to pin my screen. Everyone, please pin my screen. Because it is showing me I'm sharing my screen. I cannot help otherwise. You need to pin my screen.
Ma'am, we have already pinned up. It's not visible, ma'am.
There might be
So
network
in that
problem.
case, how I can teach?
Yeah,
Ma'am,
network
your sound is
problem.
also breaking.
Yes, ma'am, even your voice is
Okay.
also breaking in between.
Chanchal madam, please switch off
Okay,
your
because I
video.
have connected.
Please switch off your camera.
I have, sir, I am using through my mobile, and it is a problem of data.
Ma'am,
Voice
you
is
can
not
switch off your camera.
Ma'am, it is a problem of data. If I use my camera, it will consume the data. Give me a
Ma'am,
second.
now
I think light is here. Power has resumed. Give me a second. Wi-Fi will turn on and I'll connect with Wi-Fi. Give me 2 seconds.
no problem, ma'am.
Okay, ma'am.
Okay, ma'am, no
Yeah.
problem.
It happens, huh?
Thank you, Sunil sir, for understanding. Meanwhile, you can ask me queries if I am audible to you. If you have any
Yes,
queries.
ma'am. Ma'am, I need to know that how we can decide that in what data we can apply, like people use multiple regression in some of them and logistic regression, linear. How we decide when to use the different type of regressions?
You need to firstly see what is your objective. Then you need to see what type of variables you are having. For logistic regression, your dependent variable would be binary type, 0 or 1. But in multiple regression, your dependent variable would be continuous. If you want to predict a binary variable, you will go for logistic regression. If you want to predict a continuous
Okay, ma'am.
variable, numeric variable, you will go for the multiple regression.
And for linear, ma'am?
Linear is very simple. As I already told you, both the variables should be continuous numeric.
Okay, ma'am. Ma'am, for binary, can you give me the example?
Say for example, if I want to say how many or whether the means it is 0 and 1. Say for example, whether the participants will attend this workshop or not. I want to predict it. So 0 and 1, whether they're attending it, yes. Whether they're not attending it, no.
Okay, it shows the probability of.
Probability,
Okay, ma'am.
yes.
Few things. Okay, ma'am.
Yes.
Thank you.
Yes. Few more seconds. I think it is blinking, but still it is not on.
Okay, no problem.
Yeah, thank you, sir. Any other queries if you are having, you can please continue asking the queries. It is connected. I think I am audible now properly.
Yes,
Yes,
ma'am,
yes.
you are.
Okay, fine. Okay, I have shared my screen also, and now will you please confirm me whether screen is visible or not?
Yeah, it
Yes,
is
ma'am.
visible,
Yes, ma'am.
madam.
Yes, ma'am. Okay, fine. Thank you.
Madam, if erratum is more, that means the relation between the variables is not proper, or what, madam? If erratum is more.
Means your model is not good fit. Your model is has not that much capacity to predict your dependent variable. If error terms are more, that means it is your model is not good model. It is not a good fit.
Good fit.
Hmm.
Okay.
That means
Fine.
there are more error term. Means your actual and
Yeah.
predicted value, whatever the difference you are taking, it is coming as very large in magnitude. So it is not acceptable.
Not a,
Yes. And
okay,
I
ma'am.
think
Thank you.
yesterday one of you have asked me a question related to machine learning. In machine learning, generally we are doing this. We are trying to use various types of algorithms to predict the dependent variable. Using that, we are trying to reduce that error. Is it fine, sir? May I proceed? I hope this slide was clear.
Yes, ma'am.
Yes. Now,
Yes, may I proceed?
yeah, thank you, sir. So usually to perform regression in Excel, we are having a data analytics tool pack. Using that, you can easily perform. But if you want to get the different values using the functions also, so that way to get the intercept value, you can use the intercept function. To get the slope value, you can use the slope function. And similarly, for getting the Linus function, we are using for the linear function or estimation. So that also you can use, right? So we will see all this in the Excel once we will moving towards to the Excel, right? Now, as you talk about Excel, so there is a limitation in Excel. If you are having 16 predictor variables, right, you can have maximum up to 16. If you are having more than 16, means if you are having more than 16 independent variables, in that case Excel would not be able to perform multiple linear regression. This is the limitation of the Excel. Is it okay? Fine, everyone?
Yes.
Okay. So I think this was the conceptual aspect of the regression which I want to discuss. Now I request everyone to move to the Excel and please open the third sheet with the name regression. Open, everyone, regression. I hope opened.
Yes, ma'am.
Okay, fine. Thank you.
Yes.
So now you can see in this sheet we have two variables. We are having the COVID cases and we are having the mask sold, right? Now you need to firstly decide which variable you are taking as a dependent, which variable you need to take as a independent variable. Which variable we are taking as a dependent here? Anyone?
Ma'am, COVID cases.
COVID is a independent variable and mask is a dependent variable.
Dependent variable will be mask.
Okay.
Dependent variable is mask.
Dependent variable is mask
Mask,
sold.
yes.
Yes, and independent variable will be COVID cases. Right. So it is clear to us. Now you need to formulate your hypothesis. So we will see how we can formulate the hypothesis in case of regression. So you can write, I hope the size is fine. Is it visible to everyone? Do I need to increase it?
No,
Is it
ma'am.
visible? Okay.
Visible.
Okay. You can
Okay.
write, fine. You can write there is no significant impact of number of COVID cases on the sales of masks. This would be your hypothesis for this particular data. Is it clear? We want to see whether the number of COVID cases are impacting the sales of mask or not. Is it fine?
Okay.
Yes, ma'am.
Okay. If it is okay, what you need to do? Now you need to directly go to the data menu. Use your data analysis toolpack. In this, go down and search for regression. I think someone is on road and maybe trying, maybe attended the session. Okay, so we are selecting here the regression. I am pressing here okay. May I? Everyone has found it. May I press okay?
Yes, ma'am.
Yes, madam.
Yes. Thank you. Now you can see here we need to pass in the first section, we need to give the range of our dependent variable and then we need to give the range of our independent variable. So dependent variable was, that is why, was our mask sold, right? So I'm selecting the data for mask sold under the input by range. Is it fine, everyone? May I switch to the next range selection?
Yes, ma'am. Please.
Yes.
Yes. Now input X range, that means we need to select the X variable, that is our independent variable, which is the COVID cases. You can select the entire data using your mouse. That is I have done at my end. I think you also have done. Coming to the next section, we have selected our data including the labels. I'm selecting, sorry, I'm checking the box for labels. Is it fine?
Yes, ma'am.
Constant is 0. You do not need to make it 0. Constant means that y equals to a plus bx. So it is saying, do we want to keep a as 0? No, we do not want to do. We want to get its value, right? Confidence level will be 95%. If you want to make any changes, you can select it and you can make changes. If not, it would be fine, right? Coming to the next, output options. You can select your desired place where you want to generate your output. I have selected a cell where I want to produce the output of the regression like this. Is it fine? May I
Yes,
go
ma'am.
ahead?
Yes, ma'am.
Yes.
Good.
Yes.
Okay, thank you. Now come to the residuals, and although you do not need to touch anything, once you will press OK, even then Excel will give you output. So I request everyone to please press OK to get the output. I hope everyone is getting output.
Yes, ma'am.
Yes, fine. So if you are getting the output here, I'll explain you all these points one by one, the interpretation of these points. If you want to make a note, you can note down the explanation in your Excel only, right? So firstly, we are getting the value of R. R means it is the correlation. So I think I forgot to tell you this thing when I was discussing the regression or the conceptual aspect of regression. So regression means for regression, correlation is a prerequisite. Means to perform regression, firstly you need to check whether the two variables are related or not. Usually, whatever software we are using for performing regression, every software will give you the value of correlation. So the Excel is also giving us firstly the value of R. So this value is coming as 0.98. Is it fine? So this way you can say it is strong positive correlation between mass sold and the number of COVID cases. Is it fine?
Okay.
So as
Okay.
as the COVID cases will increase, the sales of mask will also increase. Coming to the next, R square. R square is known as coefficient of determination. Is it fine? R square is known as coefficient of determination. Now, you can understand its meaning. I'm explaining the meaning now. So, R square coming as 0.96. So, R square indicates the variance. You can write the percent variance in dependent variable by the independent variable. R square indicates percent variance in the dependent variable by the independent variable. So we can say 96% variance in the mask sold is represented by or explained by COVID cases. So R square indicates the percent variance explained in DV by IV. Is it clear? Everyone, it is fine?
Once again.
Yes.
Once again, madam.
Okay. So R square shows percent variance explained by IV in the DV. Means I can say 96% variance in the dependent variable, that is mask sold, is explained by the IV, that is number of COVID cases. So this should be high usually. Means how much capable is your IV? This is what we are checking here. So our IV is explaining 96% of mass sold. Is it clear?
Yes, madam.
Okay, fine. Coming to the next. Adjusted R square, you do not need to report in case of simple linear regression. If you are using multiple linear regression, you will report adjusted R square and not the R square. For the simple linear regression, you need to only report R square. Fine. Coming to next, it is the standard error, which is 141.84. Number of observations were 12. Coming to the next, we are getting the ANOVA table in the regression also. So the ANOVA value is coming as F is coming as 242.64 and its significant value is 2.4 10 to the power minus 8. So you can call, it means ANOVA table will tell you whether your model is a good fit or not. So if the significant value is less than 0.05, which it is, so we can call it that our model is a good fit. You can conclude that model is a good fit. This is the meaning of this significance value. Is it clear?
Yes, ma'am.
Coming to the next section, talking about the coefficient figures. So your intercept value, that is the value of A. So your A is coming as minus 245.63 and your B is coming as 0.9946. Is it okay? Is it fine, everyone?
Okay, ma'am.
Now the important thing which you need to check in this table, which is the t statistic along with its p value. So it is very important to see, you need to check this thing whether the p value for your t is less than 0.05 or not. So you can see in both the cases this p value is less than 0.05. So the meaning of this is that both intercept and the COVID cases are significantly contributing to your dependent variable. Is it okay? Is it okay, everyone? Hello?
Yes, ma'am.
Okay. So we can say that both A and B are significantly contributing to the dependent variable. Now we are creating a line that is y equal A plus Bx. Now we are coming here. Y was sales of mass, which is equals to minus 245.63 plus 0.9946 into number of COVID cases. This would be your line. If number of COVID cases data you are having, that you can put here, and that way you can predict the sales of mass. Is it okay?
Okay.
Okay, ma'am. Okay, ma'am.
Fine.
Madam, epsilon value not included, madam. Erratum value.
Sorry, sir. Sir, that value you need to predict. That value you need to predict now.
Okay.
You will go on this data analysis again. You can put on OK. I think this will give you the residual value also. So once you will put on OK, it will ask you to generate the output, I think. This is what you will get. Residuals are coming here. You can see. For all the 12 observations, you are getting these residual values. Fine?
Okay. Fine.
Okay. So, friends, this way we can perform simple linear regression using Excel. Is it okay? May I proceed with the multiple linear regression? Any
Yes,
doubt
ma'am.
so far? I think no voices are coming.
Yes, ma'am.
I think we
I
need
think
to do
people are so much
practice.
engrossed in learning regression. Is it something?
Actually, ma'am, we need to do practice on self
Yes,
that we interpret the data.
obviously. Because in demo sessions, because these are nothing but these are the demo sessions, ma'am. I can only explain, you people can note it down. And then you need to take your own data, and then you need to perform, and then you need to interpret by your own.
Yeah, ma'am. Yeah, sure.
Yeah. So I think I have given you the extra sheets also in this demo files. You can see, and you can perform by your own, and then you can interpret. Is it fine? May I proceed?
Yes.
Okay,
Yes.
ma'am. Yes.
Now I expect everyone to open MLR, multiple linear regression worksheet. Open it. Is it fine? Everyone able to see my screen, right?
Yes, ma'am.
Suppose in this sheet we are having three variables x1, x2, and y. Y means this is our dependent variable. X1 and x2 are our independent variables, right? So now you need to predict your dependent variable y using x1 and x2. So it is a case of multiple linear regression because we are having more than one independent variable, that is x1 and x2. Is it okay? May I start performing?
Yes, ma'am.
Yes, ma'am.
So firstly, you can write your null hypothesis. There is no significant impact of x1 on y, and there is no significant impact of x2 on y, right? Is it fine?
Yes, ma'am.
Done. Now go to the data analysis toolpack. Click on this. Select again the regression and press OK. Here you need to remove all the previous ranges which we have done and make it very simple. That it is the way the way it was looking on a fresh sheet like this. Is it fine? May I proceed?
Yes, ma'am.
Yeah. Now in the first section, input y range, you can select your variable y. Come to the next and select your both the variables or both the independent variables x1 and x2 together like this. Select the labels. Select the output wherever you want to. Select a cell where you want to generate your output like this, and then you can press OK. Is it? I think I am ready with the all the selection. I need to only press OK. So may I?
Yes, ma'am.
Okay. So I think output is generated for us. You can see again. We can see the R is coming. The multiple R is 0.83, which is indicating that there is a strong relationship between the three variables, that is dependent and both the independent variables. Coming to the R square, which is 0.69. So it shows that approximate 69 or approximate 70% of your Y is explained by X1 and X2, right? But as I said in the previous sheet, in the case of simple linear regression, rather than reporting R of the both are independent variables x1 and x2.
Your volume
and correlation also, right? So I think it is all from my side for the day. Now the platform is open for the question and answer. If you have any queries, you can ask me.
Ma'am, could you please explain? There are two types of regression lines, y2x and x2y. Is there any difference, ma'am?
Sorry?
I heard there are two types of regression lines, y2x and x2y.
I think
Is
you want to say y on x and x on y, is it?
Yes, yes.
Usually in books, always we are studying y on x and x on y. So depending upon you, if you want to take your x variable is dependent, you can create x on y also. If your variables are like that, both the variables you can treat as a dependent variable, you can create it. It is up to you.
Okay, selecting any one variable dependent or independent depends upon our choice. Right?
Your choice, and it should be that means that variable should have that capacity to explain or impact other variable.
As we did in COVID-19 case.
Yes.
Okay.
So I think mask sold and COVID-19 cases, as we have seen already, right? So it is quite clear. Sales can be predicted using the number of COVID cases, but we cannot predict COVID cases using the mask sold.
Yes, yes, yes.
So if it is a two-way relationship, so up to in that case, it is up to you which variable you are taking as a dependent, which variable you are taking as an independent.
Okay.
Okay.
That is my y value is to be calculated, then y on x, and x value is to be calculated, then x on y.
I'm not getting it, Somnath sir.
So, ma'am, y value is to be calculated, then y on x is to be applied.
Obviously, if I am saying y on x, so it is quite clear I am keeping y as a dependent variable. If I am saying x on y, I am saying x is my dependent variable. Right?
Okay, ma'am. Okay, ma'am.
Yes. I think one query coming in the chat box, Anjali ma'am is asking if level of significance is 10%, then does the p-value changes from 0.05? Ma'am, p-value will remain same, but the comparison you are making, it would be 0.1. Because in this, up to whatever we have did, we are getting the p-value and we are comparing it with the level of significance. So whatever p-value you are getting, you will compare it by the you will compare by that level of significance value. If you are taking the level of significance as 10%, so in that case, it will be 0.1. I hope you got an answer, right? Anjali ma'am, I hope you got an answer, right?
Yes, ma'am, I got it. Thanks. Thanks.
Yeah. Anything else? No more queries then? Can we end the session after taking a photograph?
Okay, ma'am. No problem.
Okay. So,
Thank you a lot for the
sorry.
Thank you,
Someone
ma'am.
is-
A lot for the wonderful sessions.
Okay. Thank you so much, ma'am. Thank you so much. Before ending, I request everyone to switch on your cameras if you can. Oh, that's great. I can see the faces. Give me a second. I'm capturing just a minute. Please do not switch off. Yes, I captured. So thank you all.
Thank you, ma'am.
This is all from my side for the day.
Thank you, ma'am.
Tomorrow,
Thank you, ma'am.
thank you so much. Tomorrow, what we are going to do, we will do a session on case studies. I'll show you some situations tomorrow, and then whatever we have studied in last 4 days, I'll try to ask you whether you people are able to identify which test is applicable on those situations, right? So tomorrow session would be very much two-way session. I will speak less and I'll expect you people to speak tomorrow. Okay?
Okay, ma'am.
Yeah.
Thank you, ma'am.
And
Yes,
after completion of this training, madam, we will get certificates, madam, regarding
Usually, sir, it happens in RFI. They provide certificate after the end of the workshop. So probably after tomorrow, in a week time, you will get that.
Oh,
Okay,
nice, madam.
Thank you so much.
Thank
Ma'am,
you.
tomorrow you will take the exam in social sciences also.
Sorry?